Hi everyone, welcome to today's live stream. My name is Elizabeth and I'm here on behalf of the Hubble Space Telescope outreach team at NASA's Goddard Space Flight Center. Today we're so excited to share newly released Hubble images of 30 beautiful celestial objects in honor of Hubble's 30th anniversary year. We're live now on Facebook and YouTube, so feel free to comment your questions and we'll try to get to them later in the show or afterward on social media. So this has been quite the landmark year for the Hubble Space Telescope, which has been orbiting above Earth's murky atmosphere for 30 years, since April 1990. Hubble continues to bring us stunning discoveries and images of our universe. Joining me today, we have Hubble's Senior Project Scientist, Dr. Jennifer Wiseman, and Deputy Director for Science Communication, Dr. Michelle Thaler. Let's go ahead and take a look at some of these new images now. All these objects belong to something called the Caldwell Catalog. These images are really gorgeous, aren't they? So the Caldwell Catalog includes galaxies, star clusters, and nebulas, which are clouds of dust and gas in space. Let's go ahead and jump right in. First up, we have an image of Caldwell 45. Caldwell 45, this is a gorgeous spiral galaxy, and it has something called nuclear rings. So Jennifer, can you explain what that means?
Sure. So this galaxy, just spectacular in this image, is showing off its big spiral arms, which you can see reaching around the outer parts of the galaxy. You can see a lot of dust in these spiral arms, and you can see these kind of purplish hot spots. These are regions where star formation is particularly active, and the bright light from those massive stars is ionizing the gas, giving us these beautiful colors. In the core, you see this glow of yellowish light. There's so many stars there that the starlight just kind of blends together. And around the center of this galaxy, we have a ring of particularly bright emission. This is caused when the conditions are just right in galaxies like this for intense star formation. So this galaxy is producing new stars at a high rate, and in particular in that ring around the nuclear part of the galaxy.
Yeah, it's really beautiful. We've got another image of a spiral galaxy, Caldwell 36. So Caldwell 36, it seems like we're almost missing a chunk of the photo here. So what are we seeing, Jennifer, or not seeing?
That's a good question. So first of all, you see that it's a beautiful spiral galaxy, another case of just a marvelous windmill type pattern of spiral arms with lots of stars, star formation, dusty regions. That kind of stair-step shape in the upper right is actually an aspect of the camera that was used to take this image. The Wide Field Planetary Camera 2 is almost like having 4 cameras in the 4 quadrants of this region. And the upper right quadrant, that camera actually can see things in higher detail than the other 3 quadrants, the other 3 cameras. So if we want it all to kind of be at the same resolution, we have to shrink down the image from that upper right camera or that upper right quadrant so that it matches the same resolution capability of the other 3 quadrants or the other 3 camera pieces. And when we shrink it down, it kind of gives us this resulting stair-step pattern in the final image. But if you can kind of ignore the stair-step pattern, you can see the gorgeous, gorgeous central part of this galaxy and the spiral arms around it. And again, another example of nature's spectacular means of arranging stars and continuing the production of new stars in active spiral galaxies like this one.
Yeah, thank you, Jennifer. We've got another beautiful galaxy image of Caldwell 29. So at the heart of Caldwell 29, astronomers suspect that there is a supermassive black hole. So Michelle, could you tell us more about what black holes are?
Oh, absolutely. So, the amazing thing about a black hole is that it's a region of the universe where gravity is so extreme, it can actually suck light in itself, and that's why we call them black holes. Now, normally we think of black holes being formed by stars that die and their cores collapse under the force of gravity. But in this case, we're talking here about a supermassive black hole. In the center of a galaxy, black holes can get to millions or even billions of times the mass of our sun. So this galaxy has a particularly mysterious, bright center. And although we're seeing visible light here in Hubble and maybe a little bit into the ultraviolet and infrared, what we also measure from this galaxy is X-ray light. X-ray light is only naturally produced when the gases reach temperatures of over millions of degrees. So as things fall in closer to this huge black hole, they get caught by the black hole's gravity and accelerated faster and faster around, almost like water going down a drain. All of that friction heats the gas up to millions of degrees, and it flickers on and off in X-ray light. So in the core of this galaxy that you're looking at here, there is a monstrous, huge black hole. And one of the big mysteries that Hubble and other telescopes are trying to solve right now is how black holes can actually grow that big. Millions or billions of stars must have gone into that black hole.
Wow. So the Caldwell catalog also contains something called planetary nebulas, like this image of Caldwell 56. But the term planetary nebula is a little bit misleading. So Michelle, what are we looking at?
Well, sure. So here we're looking at something closer to us. When you look out to galaxies, you're looking at things that are millions or tens of millions of light years away. In this case, this is a nebula, a glowing cloud of gas that's in our own galaxy, about 1,600 light years away. And as you mentioned, we call these planetary nebulas, but unfortunately that name was picked before we really understood what they were. We saw all this glowing material around a star, and we thought, hey, maybe there are planets forming. But instead of the birth of a solar system, what we're actually looking at here is the death of a solar system. Planetary nebulas are formed when a star begins to die, and it bloats up to huge sizes, then begins to drift away into space. And what's left at the very center of this nebula is a white dwarf star, a star that's actually just lost its nuclear reactions entirely and is slowly cooling off. So this is a wonderful planetary nebula that it's a little bit poignant. We're actually looking at the death of a solar system. And that's the gases that you see glowing here being unraveled from this dying star.
Very cool. Thank you, Michelle. So the next cosmic object we're going to look at is Caldwell 73, which is a globular cluster. You can find Caldwell 73 in the southern skies with binoculars. But Michelle, what exactly is a globular cluster?
Oh, these are absolutely wonderful. These are the largest star clusters that are part of our galaxy, the Milky Way. They orbit around the Milky Way, but not actually usually in the disk of the Milky Way. We are in this disk of gas and dust going around. The globular clusters are going every which way around the Milky Way, sort of like a swarm of angry bees, and they are huge. This particular globular cluster, the center of it is about 40,000 light years away from the sun. And it has the mass of over 500,000 suns. And because we think that most of the stars in this globular cluster are actually not as massive as the sun, that means it probably has 1 million stars or more. The amazing thing about these globular clusters is they're also very old. So this particular cluster we estimate to be a little bit over 9 billion years old. And when you think about the sun being somewhere between 4.5 and 5 billion years old, this is an old cluster indeed. So these clusters may give us clues about how the galaxy formed and even what the universe was like many billions of years before the sun and the earth formed. So it's absolutely lovely. I mean, doesn't it look like sort of scattered diamonds and jewels on black velvet? You know, I've had the privilege to be looking at this cluster in the southern hemisphere. And even through a small telescope, it is absolutely spectacular.
Yes, it definitely is. Now, one of the coolest things about Hubble is that it can look at cosmic objects in different wavelengths of light. So let's take this image of Caldwell 52. Hubble was able to image this galaxy, this elliptical galaxy, in both visible light and infrared. So Jennifer, when Hubble is looking at an object in the infrared, what is that telling us?
Well, we are so fortunate that Hubble is able to look at objects like this galaxy with different kinds of eyes, if you will. Certainly we can look in visible light, but Hubble also has the capability of taking in ultraviolet light, which is bluer than blue, and also somewhat into the infrared part of the electromagnetic spectrum of light, so redder than red. When Hubble looks at visible light, it's capturing starlight in visible light, and also sometimes you can see regions where dust in the galaxy is blocking out some of that starlight. So you can kind of see the blockage there. When we look in the infrared part of the spectrum using Hubble's infrared capabilities, we can see more of the reddish stars throughout the galaxy and more of the emission coming from dust throughout the galaxy as well. Kind of the glow from dusty regions, heated regions. And if we can combine what we see in infrared light with what we see in visible light, we get a much richer picture of what we're seeing in that galaxy. We can learn a lot more. So in the Hubble image, you can actually see the infrared picture up in the top middle, the visible light in the bottom, and the combination of the two in the upper right. And you can see how much we can see and learn a lot more by having both visible and infrared light combined.
Definitely. And Jennifer, even after 30 years, Hubble is still bringing us amazing views of the universe. So could you tell us what this landmark anniversary means for the mission?
Well, we are delighted that the Hubble Space Telescope is working very well, even though it's been operating in space for 30 years. It's a satellite in orbit around planet Earth. It was launched and deployed by the Space Shuttle back in 1990. And thankfully, we've had several return visits from astronauts to the Hubble Space Telescope over the years. Each time astronauts have returned to Hubble, they've been able to repair things or install new and improved instruments, including science instruments. So we now have on Hubble a really fantastic suite of cameras and spectrographs. We have good gyroscopes and batteries that help us be able to operate the telescope and point it accurately. And we're confident that the Hubble Space Telescope will be able to operate well for quite a few years to come, hopefully throughout most of this decade and maybe beyond. And that's good news for science, because Hubble right now is really at the peak of its scientific capability, even 30 years into its mission. We're doing things with Hubble now that we hadn't even imagined before it was launched, like studying the atmospheres of exoplanets, planets orbiting stars other than our sun, outside of our solar system. And we're looking ever more deeply into the universe at distant galaxies as well, understanding the history of the universe. We are also looking forward to Hubble operating in complement with the James Webb Space Telescope that is due to launch the latter part of next year. When Webb launches and operates, it will be a wonderful telescope that's very adept in the infrared part of the spectrum, looking deeper into the infrared than Hubble can achieve, whereas Hubble can see visible and ultraviolet light that the Webb telescope won't see. So in complement, these two observatories will be a very powerful tool for understanding distant galaxies, the early universe, and also star and planet formation in our nearby our own galaxy as well. So we're very excited to celebrate Hubble's 30th birthday, both for looking back, but also for looking forward to what we're going to learn about the universe in the coming years.
Fantastic. So if you're just joining us, we're live and talking about newly released Hubble images of objects from something called the Caldwell Catalog. The coolest part about the Caldwell Catalog is that you can find these cosmic objects in the night sky with telescopes, or sometimes even with just binoculars or your eyes. But what exactly is the Caldwell Catalog? Joining me now, we have Hubble's Science Operations Manager, Kevin Hartnett, and our lead science writer, Vanessa Thomas. They're also both amateur astronomers, which means they use their own telescopes to look at the night sky. So Vanessa, you were responsible for pulling together this collection of images. Could you tell us what the Caldwell Catalog is and what its purpose is?
Yes, of course. The Caldwell Catalog is a collection of 109 celestial objects, galaxies, star clusters, and nebulas that, as you said, can be seen with amateur-sized telescopes, and sometimes they are bright enough that you can see them with binoculars or even the naked eye. And the collection was put together by a man named Sir Patrick Moore, and he was a British amateur astronomer and science communicator, and he put the collection together for fellow amateur astronomers to have some targets to look at with their own telescopes. He found these objects interesting and wanted to share his list with others, and it was inspired by a more famous catalog that was put together even earlier called the Messier catalog. That was put together by a French astronomer, and that also included galaxies, star clusters, and nebulas that amateurs can see with their own telescopes. The difference between the two catalogs is that Messier's catalog included only objects that could be seen in the northern hemisphere, where the Caldwell catalog includes objects that can be seen in both the northern and southern hemispheres. So wherever you live in the world, you can see some of the Caldwell catalog objects.
That's awesome. Thank you, Vanessa. So Kevin, speaking of finding these Caldwell objects in the night sky, you actually took an image of Caldwell 14, which is the double cluster in the constellation Perseus. Let's go ahead and take a side-by-side look of the image you got and the image that Hubble has. Both images look amazing, so could you tell us a bit more about them and how people could find Caldwell objects in the night sky?
Sure. Well, Caldwell 14 is an amazing object, and this is a great time of the year to see it. It's located in the night sky between the constellations of Cassiopeia and Perseus, and is frequently called the double cluster in Perseus, and you can see why. With a small telescope from a dark site, you can see basically what I've imaged here. Two distinct open clusters of stars, each with hundreds of glittering members. It's really an unforgettable sight. If I could have the next graphic. This graphic shows the location of Hubble's image in the greater context of the double cluster. One thing stands out immediately. Hubble's field of view is tiny compared to the size of the double cluster. It would take Hubble Space Telescope hundreds of images all stitched together to form a big mosaic to capture all of Caldwell 14. This is one of the reasons why NASA is preparing the W1 mission, because this space telescope with one shot will take all of Caldwell 14 with the resolution of the Hubble Space Telescope. Now, how do we find the Caldwell objects in the night sky? Well, if you don't have a motorized go-to telescope, you'll need different things. First, you'll need a good listing of the objects and some detailed star charts for where to find them. Now, these thankfully are easily available online or in an atlas or even in a phone app. Second, you need a dark spot. Get out away from city lights if you can, and let your eyes dark adapt to the night sky, and you'll begin to see those fainter stars and constellations that you can't see from the city location. It's helpful at this in this regard to go out on a night when there isn't a bright moon in the sky. Then you need to choose your optical aid based on the brightness and the size of the object that you're looking for. So again, you can use anything from binoculars like these 7x50s, which are great, or a small telescope like this 3.5 inch here, or for some of the fainter objects, something in a 6-inch class like this one here. So the final thing is really to remember patience and persistence. This is a treasure hunt. And imagine what it's like to see with your own eye in the telescope the light from a distant galaxy that's millions of light years away. It's really worth it. It's unforgettable.
Thank you so much, Kevin. Before we jump into some audience questions, let's check back in with Vanessa. So Vanessa, there are more images and information about the Caldwell catalog online. So could you tell us more about what we can find on Hubble's website?
Absolutely. If you go to nasa.gov/Hubble, you will find a link to our Caldwell catalog, and there you'll find some background information about the catalog and Hubble's images of these objects, and you'll see a gallery of all of the objects in the Caldwell catalog that Hubble has observed and we've released images of. And you'll see some of the new ones highlighted in new. And if you click on one of those objects, you'll get the full image. And you may even see more images than just one, because sometimes Hubble has seen more or taken more than one image of an object. And you'll find some information about that object as well as how to observe it. You'll see a basic star chart that'll give you an idea of where the object is located in the night sky, and it'll tell you what constellation it's in and what time of year to look for this object. If you look at the description, it'll give you more detail about whether it's in the northern hemisphere sky or if it's in the southern hemisphere sky, and whether you need a telescope or binoculars or if you can see it with naked eye.
Great, thank you. All right, now we're going to take a look at some questions. We have one from Facebook. Okay, so what can Hubble tell us about elusive phenomena like singularities and gravitational distortions? Jennifer, would you be interested in that, or Michelle? Feel free to jump in.
I can take a shot at it. We are able to see the effects of some of these unseen phenomena. So let's take dark matter, for example. We now know that the majority of mass in the universe is unseen. It's dark matter, but we know it's there because of its effects, its gravitational effects. One of those effects of dark matter is to actually distort space-time. All mass actually can do this. And if you have a lot of matter together, such as in a cluster of galaxies, there's a lot more dark matter than the visible starlight. And that can actually distort space-time significantly enough that when we look at that region with the Hubble Space Telescope, the light coming through that distorted region from a background galaxy will get magnified and distorted, stretched out. Sometimes we'll see multiple apparitions of that background galaxy. We call this gravitational lensing. And through it, we're able to discover and detect and map out the distribution of dark matter in that cluster of galaxies, even though we can't see the dark matter. And we can also learn things from the background galaxies that are very distant but are getting magnified by this effect. So that's one of these sort of unseen phenomena that Hubble is very good at studying because we can see its effects through gravitational lensing. We're also contributing to the study of dark energy. This is the mysterious force that seems to be propelling the expansion of the universe to faster and faster rates. Hubble, as well as telescopes on the ground working together, were used to actually determine that our universe is not only expanding but accelerating, and we're using these telescopes to get a more precise measurement of that rate of expansion of the universe now and the history of that expansion over time. We don't yet know exactly what dark energy is, but Hubble is giving us a lot of new information to help us find out.
Great, thanks, Jennifer. Okay, one other question we have. So are these actually photos taken by Hubble as it is, or is it like a reconstruction of raw images? So maybe if someone wants to talk about how we get the Hubble images that we see today briefly. Let's see.
I vote Vanessa.
All right. Sounds good.
I can take that. So Hubble takes images in black and white actually through different filters. So it uses filters to isolate the type of wavelength that astronomers want to observe. So Hubble's images actually come down black and white, and to get color images, we have to take multiple exposures in multiple filters. So we put those multiple filter images together to create these beautiful colored images that you see. And yes, and we do additional processing. Sometimes Hubble takes multiple images of an object because maybe the object is too large to fit in the field of view. So we have to take multiple images to get the whole object, or to get more of the object of interest. And so we have to mosaic those images together as well. So there is some processing that goes on, yes.
Gotcha. Thanks, Vanessa. Awesome. Okay, so on Facebook, it sounds like we have someone who is a beginner amateur astronomer looking for some tips. So Kevin, do you have any words of wisdom?
Well, my best tip for folks that are getting into astronomy is to find a friend to do it with. Now, one has to be careful these days because of COVID, of course, to be in a group doing this, but there are clubs, many clubs out there for amateur astronomers. And if you join a club, which meet virtually now, you can learn a lot about different types of telescopes, different tricks to observe, and it's all very helpful rather than trying to do it alone. So that's really perhaps the best tip that I can give you. Don't do it by yourself, or if you feel like you have to because of COVID, take advantage of online meetings or YouTube videos. There's lots of them out there that describe telescopes or binoculars and how to use them. There's a wealth of information online these days.
Great. Thank you, Kevin. All right. I think we're just going to do one more from Facebook. How far away is Hubble from us? So anyone want to take that one on?
I can take a jump at it, but it's about 300 and it varies actually, but varies between about 340 and 360 miles above the surface of the Earth over the years of its mission. It's not that far away from the surface of the Earth. It's in low Earth orbit, again, not to get it a lot closer to the things that we're trying to observe with Hubble, but to simply get it above much of the Earth's atmosphere so that we don't have to look through that turbulent atmosphere that can actually blur the images that we're trying to look at. And also the atmosphere of the Earth actually filters out some of the light that we want to capture with Hubble, like ultraviolet light. So it's not very far up. It was deployed there also because that's where the space shuttle could go. And we wanted to use the space shuttle to take the Hubble up into orbit and to return to visit it several times. You should note, however, that a lot of telescopes now in space, and there are other space telescopes now and also in the future, are not being put in low Earth orbit. Some of them are being put much farther away. The James Webb Space Telescope, to be launched next year, the latter part of next year, will be 1 million miles away at a place in space called L2 that is quite far away. We want to keep the Webb telescope very cold. We want those sun shields that you see in the image there protecting the telescope from sunlight and heat to be effective. And we want to be able to have the most sensitive infrared observations possible. So that's why the Webb telescope will be put much farther away from Earth than Hubble was put.
Absolutely. I think we do have time for one more question, and maybe Michelle can take this one. Speaking of James Webb, which is coming next year, is Hubble getting upgraded after James Webb, or what are we looking at with the future of our space telescopes?
Well, right now there is actually no plans to visit Hubble with the astronauts again, and part of that is because we don't have the space shuttle. So Hubble is not actually in the correct orbit. The space station, for example, is in a very different orbit than Hubble. So we hope that Hubble keeps working as well as it is now, maybe even for a decade. The last mission that went up there in 2009 replaced a number of the cameras. So the cameras are actually much younger than 30 years, just a little bit more than 10 years old. And they also did things like replace gyroscopes so that the telescope will be able to point itself very well. So, some of the things that I'm really excited about as far as what we're doing in the future of Hubble, we're working on, for example, catalogs that astronomers all around the world can use, catalogs of say, star regions where young stars are being formed right now. Another thing that we're doing that I'm very excited about is monitoring the atmospheres of planets like Jupiter and Saturn. So a lot of people have heard that the red spot of Jupiter is shrinking, and it's actually changing color as well. So Hubble will be doing that too. So Hubble has a huge future ahead of it. And although we're not expecting to actually upgrade it at this point, it is still going to be this incredibly relevant and wonderful observatory. And when the James Webb Space Telescope is launched later next year, the two observatories, we hope, will be able to work in conjunction to some degree. And this will allow us to do something called calibration, where we make sure that one telescope is agreeing with the other telescope. We can make our images and our measurements as accurate as they can possibly be. So that's something I'm looking forward to next year. It's going to be a big event.
Yeah, it's going to be awesome. Well, thank you all for sending in these questions. Unfortunately, we're going to have to wrap things up for today, but if we didn't get to your question here, we'll try to answer it later on social media. Thank you for joining us. We love sharing these newly released Hubble images of objects from the Caldwell catalog with you. All the images we talked about and many more can be found online at nasa.gov/Hubble. There, you can also find more Hubble content and fun online activities you can do with your family or on your own. Be sure to keep up with us on social media at NASA Hubble on Twitter, Facebook, Instagram, and Flickr. Thanks again for joining us, and have a wonderful weekend.